Okay, Algebra 2, we are starting section 09 today, and this is kind of focused on like the statistics or the data portion. For the last couple of days, we've been kind of dealing with more geometry concepts, but this is kind of like the data, the statistics stuff, like mean, median, mode, range, all that good stuff, okay? We are going to only do half of these notes today. We're going to stop right before we get to the 5-number summary. And then rather than you having an assignment out of the book, you have a page that looks like this, right? It says section 09. This is your homework page, and you're only going to do 1 through 4. 4 has an A and a B. 1 through 4 for today. So that's just the front side of this page. Then tomorrow, the assignment is the back side. So like number 5 and number 6. So just kind of separated into 2 days. This is today's stuff, and we're only going to do the first half of the notes. It's not terribly difficult, but it does take a little bit of time. At least putting like data in order and that type of thing, that takes a little bit of time. So measures of center, spread, and position. The first thing that they discuss is statistics, and it says it's the science of collecting, organizing, displaying, and analyzing data in order to draw conclusions and make predictions, okay? That we probably knew. There's a course that I teach, like seniors can take it, that is statistics. And so we will deal with data and all this stuff, okay? The branch of statistics that focuses on collecting, summarizing, and displaying data is called descriptive statistics, okay? We have some vocabulary words, and there's 5 of them that we have to match up. So the first one says data that include only one variable. And down here I see univariate, and uni means 1. So E is going to go in that spot. Data that includes only one variable. So I'm only collecting values on people's height. That's only one piece of information, okay? The next one is a characteristic that it can assume different values. That is a variable, right? Like X and Y and Z are all variables, and we can plug different things in for them. They can assume different values, okay? The next one is values used in statistics. Those are data, or data, however you like to pronounce it. The entire group of interest to a statistician, that is called a population. That's D. And then a subset of a population is called a sample, okay? So typically, when we're dealing with population versus sample, if you look over here, population versus sample, like let's say our population is everybody in the United States, so USA. And I don't want to survey everybody in the United States. That would take forever for me to collect data for everybody in the United States. So rather than doing that, let's say my sample is going to be just people in Nebraska, okay? That's going to take some time for my sample to collect all the data from people in Nebraska, but it wouldn't take as long to do that as it would be to gather data from everybody in the U.S., okay? Now, the thing that people get confused all the time is they think population always means everybody everywhere, okay? So I'm going to reverse this, and I'm going to do another example where my sample is now everybody in Nebraska, right? Before, my sample, or excuse me, my population, get rid of that. My population is now everybody in Nebraska. So before, my sample was everybody in Nebraska, but now my population is Nebraska. But if I want to find a smaller subgroup of Nebraska, I could just sample everybody in Blue Hill, okay? So population doesn't always mean every single person everywhere. It's just whatever group you're wanting to talk about, okay? And then your sample is just a subgroup within that, okay? All right, so there's that. And let's move on to some computations with data. And one of them is mean, and then we have median, and we have mode, and then range is down here, but we're also going to do that up here to this data set. I'm going to add that. Find the mean, median, mode, and range of this data set, okay? So we're going to do that here. Mean is the average. So it's like averaging up all of the data values. The median is the middle number. The mode is one that occurs the most, so it's the most occurring number. And then the range is the largest, I'll say largest, largest, minus the smallest data value, okay? And that will give me my range, all right? So example 1, they give me 10 numbers here, the number of milligrams of sodium, which is salt, in a 12-ounce can of 10 different regular brands. So there's 10 different brands of soda shown here, and we're trying to find their salt content or their sodium content, okay? Find the mean, median, mode, and range. All right, to do the mean, to do the average, all I need to do is take and add each one of these together, like add them all up, and then I'm gonna divide by the number of numbers there are, which is 10, okay? If I add them all up together, I did this already, it was 290, I'm gonna write it over here. 295. And if I divide that by 10, all I'm doing is moving the decimal, which is 29.5. So the average sodium content is 29.5. I don't know if it's milligrams. Yeah, milligrams right here. 29.5 milligrams is the mean. So I'm going to do mean here, okay? Then the median. In order to do the median, we have to have all of the data in order. So if that's something you want to do right away before you calculate the mean, you sure can, but you don't have to have them in order to calculate the average or calculate the mean. You do for the median, okay? So what I'm going to do is I'm going to put these in order, and I'm going to write them directly below the ones that are already there. So 10 is the first one. I'm going to write that directly below 50. The next one is 15. I'm going to write that directly below this one, okay? And by doing that, I know that I don't forget one, right? Because they're like matched up basically, okay? The next one is 20. I'm going to write that right below, okay? The next one is 25. We'll write that right below. Then I have 30. Then I have 35. Then I have another 35. Then I have another 35. Then I have 40, and then I have 50, okay? And since I put them right below and I got all the way to the end, I know I didn't forget a number, okay? All right, so when you are finding the median, you're finding exactly the middle, okay? Now, a lot of you guys used to do like cross, 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 blah, 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 okay? We're gonna be smart kids about this. And if we have 10 numbers, if I split that in half, I have 5 numbers over here and 5 numbers over here, and then my median is like right here in the middle, right? Okay. Now I have the numbers 1 through 5 on this side and the 6th through the 10th number on this side, okay? And if I have 10 numbers, I'm not going to have an exact number, but my median is going to be the 5th and the 6th number, if that makes sense. So rather than doing cross, 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 I can count 1, 2, 3, 4, 5, and 6. This is my median between the 5th and the 6th number. Now, if I have 2 numbers for a median, I just average these, and the average of 30 and 35, if I add them together and divide by 2, that is going to be 32.5 is going to be my median. Okay, so median, M-E-D-I-A-N, there we go. The median is going to be 32.5, okay? Then the mode and the range are the easiest ones, I feel like. The mode, range, mode is the number that occurs the most. So I have a 35 that's appearing 3 times. So that's going to be the number that occurs the most, okay? Now, let's say you have all of the numbers that are only occurring once. You would have no mode, and you would literally write no mode down for mode, okay? What you don't want to put is 0. If you don't have a mode and you don't have a number that occurs more than once, you would put no mode and not 0, because 0 could be a mode, right? Like 0 could be a number in your data set, so you don't want to do that, okay? And then range is the biggest number minus the smallest number. So 50 minus 10, which is 40 is my range, okay? So there is that, all right? So that's a lot of stuff going on already for this data. There is that, okay? All right, the next thing that we want to talk about is something called standard deviation. This is the last thing that we're going to talk about because it does take a little bit to calculate, and I'm only going to make you calculate this for one problem out of your homework. So here's how this works, okay? So we have 2 different classes, and there's 5 pieces of data for each class, all right? And these are midterm exams. So like we had a person get an 85 out of class A on their midterm exam, somebody got a 76, somebody got a 92, etc., right? And then class B was those data values, okay? Now what we have going on here is it says that both sets of scores have an average or a mean of 84.2. They each have an average of 84.2. So the average here is 84.2, and the average here is 84.2, okay? So it looks like these classes are basically the same. They're both averaging out to be about the same. But what we want to look at instead of the average, because it looks like they're the same, we want to look at something called the standard deviation, okay? The standard deviation. So When we're looking at standard deviation, the higher the standard deviation, the more spread out my data is. Okay, the more spread out my data is. If the standard deviation is lower, then that means that my data is closer together. So let me give you an example of that, okay? Let's say we can use the same 84.2, and let's say this one has a standard deviation of 5. I don't know for sure. We're going to calculate it here in a second. And let's say this one has a standard deviation of 5, and this one has a standard deviation of 10, okay? For this one, if you think about it like on a number line, 84.2 lives here in the middle, and then what we're gonna do is we're gonna add 5 to this, which is 89.2, and we're gonna subtract 5, which is 79.2. And what's gonna happen is we would say that the majority of the scores are gonna fall between a 79.2 and an 89.2, versus the class below that, which still has an average of 84.2. If it has a standard deviation of 10, I would add 10 to 84.2, which is 94.2, and I would subtract 10, which is 74.2. So I would say the majority of the values are going to be between 74.2 and 94.2. This is a lot wider range than this one, okay? So that means Class A, these scores would be closer together versus Class B is more spread apart, if that makes any sense, okay? So that's the information that we have on standard deviation. We're gonna actually calculate standard deviation for one of them on the backside, okay? So we're gonna actually do the standard deviation, and we need to remember that Class A had an average of 84.2. That's what we're gonna use onto the backside, okay? So Class A, the average was 84.2, okay? So here's how this works. What I've done for this table is I've taken 85, 76, 92, 88, 80, these numbers right here, and I've put them in a table format right here. Okay, there is that, all right? And then what we're gonna do is we take each one of those data values and we subtract the average, right? 84.2 is what we're gonna subtract from each one of those values. So I'm gonna do 76 minus 84.2. We're gonna figure out what that is. We're gonna do 92 minus 84.2. We're gonna figure out what that is. We're gonna do 88 minus 84.2. We're going to figure out what that is. And then we're going to do 80 minus 84.2. And we're going to figure out what that is, okay? And then as soon as we find this number, we're going to then square it and get another number, right? And then at the very end, we're going to add all of these numbers up and get a sum, and that's going to give me my close to my standard deviation. We'll get to that point, okay? But we're following this pattern. This is what you're going to do on your homework assignment. So make sure you pay attention to this table because this is the process that you are going to use, okay? So I'm going to go 76 minus 84.2. Let me get my calculator out. 76 minus 84.2, and then that is negative 8.2, and then I'm going to square that, which is, so I take negative 8.2 and I square it, and when you square that, this negative is going to go away. So that's going to be 67.24, okay? I'm going to do the same thing. I'm going to do 92 minus 84.2. So 92 minus 84.2, and that is 7.8, and if I square that, I get 7.8 squared. This is kind of a tedious process. That's why it's kind of a pain in the butt. That's not right. Let's do that again. 92 minus 84.2 is 7.8, and we're going to square it. There we go. I knew that number was wrong. 60.84. Okay. These numbers are all a whole lot bigger than 0.64 because 85 and 84.2 were really close together. So if those numbers are looking weird, it's not wrong, okay? We have 88 minus 84.2, and that is 3.8. And if we square 3.8, that is going to be 14.44. And the last one is 80 minus 84.2. which is negative 4.2. And again, if we square the negative, it's going to make it positive again. So I'm going to hit the square button, and 17.64, okay? The last thing we're going to do is we're going to add all of these up, okay? And let's see, 17.64 plus, I'm gonna add them backwards, 14.44 plus 60.84 plus 67.24 plus 0.64. And that is 160.8, okay?